All right, welcome to our next lecture. This one is on section 7.3, logarithms. And if we were in class, I would have you all stand up and repeat the following. Logarithms are exponents. You can repeat that to yourself where you are. Logarithms are exponents. All right, so what do we mean by that? Okay, all right, let's say, here's how we will write this. Log will be short for logarithm. We're going to have a base, 2 for this example, and I'll put an 8 in there, okay? And the way we read this is log base 2 of 8, okay? Now, what does this mean? It's an exponent. It's the exponent that you put on the base to get the 8, all right? So, what number, 2 to what number would be 8? 2 to the third would be 8. And the way I always think of this is the base to this here, which is your exponent, that's always going to be that number there. Log base 2 of 8 is equal to 3. Okay? And you can always write that in what we call exponential form. 2 to the third is 8. Okay? So the left equation here, we call that the logarithmic form. And the right-hand equation, we call that the exponential form. And anytime you write a logarithm, you can always write either the logarithmic form or the exponential form. The log will always be equal to the exponent. Okay, let's do a couple more examples here. What's log base 4 of 16? Okay, so we're asking what exponent would you put on 4 to get 16? 4 to what power is equal to 16? Well, that would be 2, right? 4 to the second power is going to equal 16. In exponential form, 4 squared is 16. Let's do, say, log base 3 of 9. Okay. 3 to what power would equal 9? 3 squared would equal 9. 3 to the second power, that's the exponent, will be 9. Okay. How about what's log base 4 of 4? Okay. Well, any number to the first power is equal to itself. Log base 4 of 4 will be 1. Okay. 4 to the first is equal to 4. And one more before we get to the calculator that's popping into the screen. Okay. What's log base 4 of 1? Okay. Well, 4, any number to the 0 power, any positive number to the 0 power, that would be 1, right? So 4 to the 0 power is 1. That's the same as saying log base 4 of 1 is 0. Okay. So let's just write out, we'll write this out in general, okay. For any base b that's positive and not equal to 1, okay, if we write log base b of x equals y, that means b to the y is equal to x. Okay. The b here has to be positive, and it can't be equal to 1. Can't be 1 because if you took 1 to any power, you would just get 1. Okay, so you would not be able to get different things. Okay, the x will always be bigger than 0. All right. Now, in all the examples we've done so far, we've been able to figure out what the exponent is pretty easily from the numbers involved. What if you wanted to do something like log base 10 of 42? Okay, So your y, if you want to think of it as your exponent, 10 to the y is 42. Well, we're not going to be able to figure that out in our heads. So what do we do? Okay. All right. Most any calculator, if you've got a calculator app on your iPad, it should have at least two different log buttons. Okay. The one I have, pCalc Lite on my iPad, there's the log base 10. You can use that button to do any logarithms if the base is 10. Okay, so if I want log base 10 of 42, I would just do 42 and hit my log base 10 button. Okay. So from the calculator, switch back to black here, log base 10 of 42 is about 1.62. You'll have a whole bunch of decimals going off to the side there. Maybe we'll do one more decimal, 1.623. Okay. Now, what this means is 10, and you can check this on your calculator, 10 to the 1.623 should be 42. Okay. If you want to check that out on your calculator, go ahead and do that. You can do that with your exponent button. 10 to the 1.623. Okay. I get 41.976. All right. And it's not exactly 42 because I rounded off. Okay. So, yes, 10 to the 1.623, I'm getting 41.976. That's approximately 42. Okay. So that log base 10 button, that there, you can use that for any logs base 10. Now, most calculators will also have a log base E button. Okay, and so, and if you don't see a log base E, you might see one that's just LN, and it might be capital LN depending on the calculator. Okay, all those mean the same thing. Okay, and this is where E is that number we looked at last time, 2.718 or something close to that, rounded off. All right. So if you want those base E logarithms, these are called natural logarithms for reasons we'll go into later. You've got a button for that. And this calculator also has a log base 2 button. Okay. All right. Now, what if you wanted to do log of a number that's not 2 or 10 or E? Okay. What about if we want, say, log base 5 of, 67 or something? Okay. All right. Again, that's going to be an exponent. 5 to some power is going to be 67. Okay. And it's probably going to be, well, 5 squared is 25, so that's y equals 2 would be too small. And 5 to the third would be 125, so 3 is too big. So this should be somewhere between 2 and 3. Okay. How would we get a calculator to tell us that value? Okay. We're going to use what's called the change of base formula. Okay. And here's that formula. Log base b of x. If you don't like the base e, you can change to base a for any other number a that's bigger than 0 and not equal to 1. Okay. Log base b of x will be equal to log base a of x divided by log base a of b. Okay. And that's what we call the change of base formula. So let's say we want to know what's log base 5 of 67. Okay. Let's change to base 10 because we can do base 10 on our calculator. log base 10 of 67 divided by log base 10 of 5. Okay? And then you would just have to calculate each of those. Log base 10 of 67 is 1.826. Log base 10 of 5 is 0.699. All right, so, and then if we do the division, 1.826 divided by 0.699, we get about 2.61. All right, so that makes sense. We expected the answer to be between 2 and 3. We got 2.61. Okay, if you want to check, take 5 to the 2.61, and you should get something approximately equal to 67. That would be your check. All right, so that's introduction to logarithms. And next, we'll do another short lecture also on 7.3 that will look a little bit about why we use logarithms, what good are they. But we'll stop this one here. See you again soon.